Before I start my presentation, I would like to use this opportunity to thank Esri Singapore for giving us this chance to speak and show what we do here. Okay, let's go. Singapore Advanced Map, our story. Okay, I'm going to talk about 3 points in my presentation today. They are data, application, and platform. This would explain why we are doing it, what we are doing with, and how we are doing it. What are the requirements for the cities of the future? The above shows the various components in the future city, being smart, sustainable, and resilient. Before we get to that level of being smart, we need to start with the basic fundamental needs, which would consist of digital data of the existing city. In short, we need maps with information. Back in 2014, we decided to map the whole of Singapore because data doesn't fall from the sky. And as a first step to the future city realization, to be prepared. In GIS, we want the data to be smart, to be workable, to give us answers, and not just look good. Multi-sensor data collection process. We try to utilize multi-sensor so that we can have as many data as we can from one project. Expensive but great savings. It will be costly, but when the data is shared by multiple parties, it prevents repetitive projects from being carried out, so the savings are actually greater. Big data extremely space hungry. We know that the data will explode and the space needed to store the raw data, to process data, information extracted from the data, and interim storage for processing work. But it will be useful for many agencies and is a developed once used by many approach. So for phase 1, we use 2 sensors mounted on a plane. The imagery plane flew in the daytime and the laser scanning plane flew at night. Some of the products from the imagery include Nadia and oblique images, LOD1 massing models, LOD2 city models, and autophotos. For the laser scanning, we have point clouds, we have our digital surveys model, and we have our digital terrain model. Growing needs for 3D information for the Foley applications include DTM for flood management, urban airflow dynamics, urban heat island, underground infrastructure, solar potential, and shadow analysis. Major requirements of smart nation is automation. Automation applications also need detailed maps and precise positioning. So this is our challenge. How to showcase the project and usefulness of the data to all. Those interested party and for ourselves, how do we use them in a platform that enable this massive data to be imported? In a format that is enable clean, neat grouping of each data set, fast, the rendering have to be beautiful, the building have to be beautiful to give the maximum viewing experience for the user. And it should be easy for the program to share the maps to other users elsewhere. The platform, Singapore Advanced Map, is a geospatial information platform that integrates our 2D and 3D mapping data. As we are current users of Esri desktop, we decided to try the latest for Esri selection of programs. It's not difficult, it's not totally the same. It's not too hard to understand as the basic fundamentals are there, and not too long of time are used and we are ready to go. So in the beginning, we just wanted to have a platform that can handle our data with minimum performance issue. But we found something from Esri Pro multi-map views. Why have one map when you can have 2? Why squeeze all the data into just one map when you can split them up for easy viewing and use? Why view everything in 3D when some data reaps more benefits when they are viewed top-down in 2D? You don't have to navigate excessively in the 3D environment when everything is just clearer when there is 2D and 3D links side by side. And data are sometimes better in 2D. So please don't forget about them. Okay. Now I'm going to do a demo, a live demo. Okay, let me see. Okay, this is our SAM. Okay, let me navigate. Okay, if you can see, this is the 3D map and this is 2D map. They actually show different things, but they are linked together. So if you, as you move further out, different informations are displayed. Like the road network on the 2D. And you move further out, all the LOD2 building get replaced by LD1. Come on. Okay, about right. Okay, let me bring you to some of the bookmarks that I have here. One of them is the data that we actually manage, which is the underground data. Oh, wait. Okay, here. So you can actually see the underground data. This is our subterranean cadastral lot under the earth. So there's data to them, and from the 2D map, okay, you can actually see where we are actually looking at. This piece here, but I'm not sure why this is not happening. Okay, let's move to our next data, which is this is the mobile laser scanning data. Yeah. We ran 5,000 kilometers of roads to get this data, point clouds. This actually enrich the whole environment because just having LOD2 and just raster drap on it, it just doesn't show you all the finer things on the ground. Like the lamp post, the tree. Okay, next one. Okay, I'm going to go to the other place, which is a Goodwood place. Let me get this. So I actually can have this slope map in 2D here. We close this, you can actually see the slope map for this area and see how steep they are. It's actually useful for planning work for our other department, because you wouldn't know when the trees will fall and how high the slope is. So by just looking at the 3D, you might see, oh, it's beautiful, oh, it's very nice. Then, but what is the true meaning of that? You can actually view it in 2D. And you can get the sense of where you are actually from 2D. Let me close this. Oh, I closed the wrong. Okay. I know a lot of people like to play with 3D. They're like, oh, so nice. Like, oh, move, wow, wow, just move around. Then it's like, oh, where am I now? But with the 2D map, you can actually get a sense of where you are. You don't have to navigate too much. So you see when the 2D is moving, you're zooming out, it actually shows different level of detail that you need. And shows the contour, you shows the lamp profile, where you here just see, okay, yeah, But it's good that you have 2D and 3D in the environment, so you can get the maximum usage for both. So let me go to another place. Oh yeah, we got trees. Let me show you trees. I just planted them. Okay, here. Trees come. I still got 2 minutes to wait for the trees to come, so we just wait. Okay, never mind. Okay, let me show you something else. We have, oh, line of sight. Let me bring you to a line of sight place. Oh, what's this? Okay, never mind. Let me do flood simulation. Okay, this is the area. Because you have accurate data terrain, you can actually do a flood model of the place at different level. Of course, this is not the way that the water will behave, because you have other factors to consider. But this roughly see where your house is and if it's going to flood or not, which I'm not going to release to you guys. Okay, so other than this, let me stop here first and go back to my slide. So with more data, there's a thirst for data. So we are looking into 3D and 4D. We are looking at sensor data. We are looking at Earth observation data, above ground, underground, indoor building level data, and beam data, and also point clouds data. We also have transportation models that we wish that one day we can all integrate into SAM, so that everybody can have use for them. Do I have anything else? Oh, thank you.